Hello YouTube and welcome back. I am Benjamin Williams and today we're going to be doing another video within Boson NetSim. Today's video is going to be on Boson CCNA challenge quiz for lab number 3. So let's go ahead and read our objective for this lab. It says in this lab you will configure Cisco iOS routing features on a network in multiple virtual local area network VLANs. You will explore a previously configured implementation of Hot Standby Routing Protocol, HSRP, and you will also configure default routes where appropriate. Finally, you will configure the Single Area Open Shortest Path First version 2, OSPF v2, to route packets between the Internet Protocol version 4, IPv4 networks. Ideally, you should complete this lab after you have completed other labs that cover this material. So, we can see that Boson provides us with the lab topology. We can see that we have 3 routers, router 1, router 2, and router 3. Router 1 and router 2 are connected via Ethernet connection, while router 2 and router 3 are connected via a point-to-point link. We can see that router 2 has a connection now to D-switch 1. Router 3 has a connection down to D-switch 2. We can see we have an ether channel or a port binding between D-switch 1 and D-switch 2. And we can see that our access layer switches have connections to both D-switch 1 and D-switch 2 for redundancy purposes, most likely. We have PCs as well down here within our lab topology. So let's go ahead and take a look at the commands that we're going to be using in this lab. We have configure terminal, which enters global configuration mode from privilege exec mode. We have enable, which enters privilege exec mode. We have end, which ends in exits configuration mode. We have exit, which exits one level in the menu structure. We have interface type number, which changes from global configuration mode to interface configuration mode. We have IP default gateway IP address. This configures a default gateway IP address to which traffic destinates to remote networks will be forwarded. We have IP OSPF process ID area ID. This places an interface in a specified OSPF processing area. We have IP route, and we have specified the destination, then the prefix, then the destination and the prefix mask, and then we'll specify the IP address, the interface type, and this establishes a static route. We have network address, wildcard mask, area ID. This activates OSPF. Let me highlight this. This activates OSPF on a specified network and places the matching interface in the specified area. Okay. We have ping IP address. This sends an ICMP echo request to the specified address. We have router OSPF process ID. This enters router configuration mode for an OSPF process. We have router ID IP address. This configures an OSPF router with a 32-bit router ID. We have show IP OSPF. This displays information about the OSPF processes that are running on a router. Okay. We have show IP OSPF, and we can specify the process ID, also the area ID, and then we have neighbor. This displays OSPF neighbor information. We have show IP route, which displays the IPv4 routing table. We have show running config, which displays the active configuration file. We have show standby, which displays HSRP information. We have shutdown, which disables an interface, and we have no shutdown, which enables an interface. We have trace RT IP address. This traces the path from a source to a destination PC. Okay. Boson also provides us with the IP addresses of each device, so we would definitely refer back to this table as needed. We can see we are supplied with the device name, the interfaces on each device, the IP addresses on each device, and also the subnet mask. This is very valuable information that we can refer back to as needed throughout the lab. So let's go ahead and get into the lab. We're going to keep our lab topology up here in the top left. I'm going to be doing my lab readings in the top right. We're going to be doing all of our device configuration down here at the bottom. Let me refresh because I am not seeing my host name as I hit enter. And that's usually an error. Yep, there it is. So that looks good. Now we're seeing the device name or the host name as I hit enter. So that looks good. Let's go ahead and get into our lab task. It says task number 1, explore HSRP. It says HSRP is a first hop redundancy protocol, FHRP, that is used to ensure devices on a local area network LAN always have a default gateway to which they can forward packets. If one default gateway in a HSRP configuration goes down, another takes over for it. In this task, you will explore an existing HSRP configuration to verify that HSRP is functioning correctly and to determine which devices are active routers. So it says allow the network time to converge, then from PC1, trace the path to PC4, which has an IP address of 192.168.200.6. So let's go and pull up PC1. We're on PC1 now, and we want us to do a trace RT command. So let's type trace RT, and we want to do it to 192.168.200.6. So let's see the path that PC1 takes to get to PC4. We can see that our first hop was to 192.168.100.2. So if we go to our IP address table and we look for that IP address, what IP address is this device on? It's got to be on, it's right here on DSwitch2, the VLAN 100 interface. So from PC1, this traffic goes to DSwitch2, and then from DSwitch2, it goes to 192.168.200.6. That's the next hop. And if we take a look, that is PC4's IP address. So it goes to DSwitch2, and then it's forwarded down to ASwitch2, and then it's forwarded down to PC4. So that is the path that PC1 takes to get to PC4. Okay? And we can see that PC1 and PC2 are on different VLANs and different subnets. So that means that this DSwitch number 2 is doing our inter-VLAN routing. Because we can see that down here, these are layer 2 switches, so they're not IP capable. Okay? So it looks good. Let's go ahead and go on to number 2. It says from PC4, trace the route to PC1. All right, so let's pull up PC4, and let's do a trace RT to 192.168.100.5. So if we take a look from PC4 to PC1, our first hop was 192.168.200.1. If we take a look at our IP address table, we can see that that IP address is associated to the VLAN 200 interface on DSwitch1. So from PC4, the traffic goes to ASwitch1 and over to DSwitch number 1. And then if we take a look at the next hop is 192.168.100.5. That should be, yep, that is the IP address for PC number 1. So PC4 sends its traffic to DSwitch1, and from there, DSwitch1 routes the traffic to PC number 1. All right. So that is how traffic is forwarded from PC4 to PC number 1. So number 3, it says on DSwitch1 and DSwitch2, issue the commands to display information about the HSRP configurations on each layer 3 switch. So on DSwitch1, let's do an enable, and let's do a show standby to see HSRP information. Let's do the same thing over here on DSwitch2. Let's do an enable. Oops. Let's do an enable, and let's do a show standby. Okay. So from this information, we can see that DSwitch2 is the active router for group 100, for the VLAN 100 group 100. It is acting as the active router. And on DSwitch2 for the VLAN 200 group 200, it is the standby. And we can see the IP addresses that are used. We can see for group 100, the virtual IP address is 192.168.100.15. It is 192.168.200.15 for VLAN 200 group 200. We can see the MAC address that is used. We can see the preemption that is enabled. And we can also see the priority that is configured. So all of this is good information to retain. Same thing over here on DSwitch1. We can see that DSwitch1 VLAN 100 group 100 is the standby, but it is the active for VLAN 200 group 200. All right, and we can see preemption details. We can see the priorities that are configured. So this is good information to have when troubleshooting or just to map the network. All right, so number 4, it says on D-Switch 1, issue the command to display the routing table. Note the gateway of last resort configuration. So on D-Switch 1, let's do a show IP route to see the routing table. And it says note the gateway of last resort configuration. And if we take a look, we can see that a gateway of last resort is not configured on D-Switch 1. If we look at the routing table, we can see that we have a bunch of connected and local routes, but no default gateway is configured, or no gateway of last resort is configured. Okay, so number 5, it says on D-Switch 2, issue the command to display the routing table. Note the gateway of last resort configuration. So on D-Switch 2, if I do a show IP route over here, similar output, it looks like over here. We can see that there is no gateway of last resort configured on D-Switch 2. And within our routing table, we have a bunch of connected and local routes. Okay, so number 6, it says on D-Switch 2, issue the command to disable HSRP group 100. So on D-Switch 2, we're already here. Let's do a configure terminal. Let's go into interface for VLAN 100. And let's do a shutdown. And that basically just disabled the HSRP group 100. As we can see from this output in the console, we can see that the status on D-Switch 2 for the VLAN 100 group 100 has changed from active to init. So I guarantee you, if we go over here to D-Switch 1, D-Switch 1 has now taken over and is the active. And yep, we can see that the HSRP status has changed on D-Switch 1. It is now taken over as the active router because we shut down the VLAN 100 on D-Switch 2. All right. So number 7 says from PC1, trace the path to PC4, which has an IP address of 192.168.200.6. So now the first hop should be D-Switch 1. Before it was D-Switch 2. If we look right here, we can see that it was D-Switch 2 before. Now it should be D-Switch 1. Let's take a look. Yep. So our first hop is now changed. Our first hop now is 192.168.100.1. And if we take a look at our IP address table, that is the VLAN 100 on D-Switch 1. So now that basically we shut down D-Switch 2's VLAN 100 interface. So and that just simulates a failure in a network. Let's just say that the interface, we didn't shut it down, but it just shut down for some other reason. D-Switch 1 will take over, and our end devices will still be able to forward traffic within the network, even if a problem occurs. So that is why we configure protocols such as HSRP. Okay, so we were on number 7. Now we want to go to number 8. It says from PC4, trace the path to PC1. Well, PC4 was already on, I think it's on the VLAN 200 interface, so it shouldn't affect its traffic at all. Yeah, it doesn't. It still uses the first hop of, I believe that's D-Switch 1. Just wanted to confirm. 192.168.200.1. Yep. So its first hop is still D-Switch 1. All right. So that looks the same. We can mirror it up here from before. It's the same exact output. Okay. So its traffic path did not change. So now here it says on D-Switch 1, issue the command to disable the VLAN 200 interface. So if we do that, if we remember, the VLAN 200 interface on D-Switch 1 is the active. So we're going to be basically shutting this down, and it will now be in the init state. If we shut it down, it's going to go from active to init, and then D-Switch 2 should take over for D-Switch 1. So let's take a look. Let's do a configure terminal, and let's go into interface for VLAN 200. Let's do a shutdown. And as we can see in the console, HSRP for VLAN 200, group 200, has went from active to init, which as I said it was going to do. And now if we go and take a look at D-Switch 2, D-Switch 2 should now be the active. And yes, we can see that D-Switch 2 has now taken over for VLAN 200 Group 200. It has now went from the standby to the active router, okay? So now on number 10, it says on D-Switch 1, issue the command to enable the VLAN 200 interface. So let's go back over to D-Switch 1 and re-enable it. So let's do a no shutdown. And that brings our VLAN 200 interface back to the upstate. And we can see that the VLAN 200 has went from init back to the active. And that is because we have preemption enabled. And the VLAN 200 has a higher priority than the default. The default is configured to be 101, as we can see. And we have preemption enabled. So it looks like D-Switch 2 has a priority of 99. Yep, so D-Switch 1 has a higher priority, so it took back over as the active router because it has a higher priority and preemption is enabled. Okay? So on number 11, it says on D-Switch 2, issue the command to enable the VLAN 100 interface. All right, so let's go to D-Switch 2. We're here now. Let's do an exit. I want to go into interface for VLAN 100. Let's do a no shutdown to bring that back up. And as you can see, it takes back over as the active because it has a higher it has a higher priority than the default. It has a priority of 101, which is higher than D-Switch 1's of 99. And we can see that preemption is enabled for this VLAN in group. So it takes back over as the active. Okay? So number 12 says from PC1 and PC4, trace the paths to PC4 and PC1 respectively. So we should be back to the defaults that we had from the start. So if we redo this trace route, we can see that our first hop is the same as it was from the first one that we did. So the first hop for PC1 is a 192.168.100.2, which is D-Switch 2. And then it goes to PC4. And if we go from PC4 to PC1, we can see that our first hop is 192.168.200.1. That is D-Switch 1. And then it's forwarded down to PC1, which has an IP address of 192.168.100.5. All right, we can see that right there. All right, so that looks good. That looks to be the end of task number 1. Let's go ahead and move on to task number 2, which says configure default routes and static routes. It says in this task, you will configure default routes and static routes on several devices in the topology. Default routes forward traffic to unknown destinations to a router. Static routes forward traffic for specific networks to a specific next hop or interface. So it says from A switch 1, ping D switch 1's VLAN 100 interface and D switch 2's VLAN 100 interface. The ping should fail. So on A switch 1, let's ping D switch 1's VLAN 100 interface. Let's do a enable. Let's do a ping to 192.168.100.1. It says these pings should fail. And if we take a look at A switch 1, we can see that it does have a connection to D switch 1 and D switch 2, but it is a layer 2 switch. So if it doesn't have a default route, it probably cannot forward layer 3 traffic. So let's do a ping to 192.168.100.2. And it cannot ping that address neither. All right, so number 2, it says, while the rest of those fail, let's go ahead and read number 2. It says on A switch 1 and A switch 2, issue the commands to configure each switch with a default gateway of 192.168.100.15 and 192.168.200.15 respectively. So let's pull up our IP address table because it should tell us what our default gateway should be. Does it tell us 192.168? No, it doesn't tell us our default gateway, but it should be. Let's see. Let's take a look at the IP address table. A switch 1 It should have a next top of 192.168.1. It should have a next top of, let's see, 192.168.100.15. Yeah, of D switch 1. Yep. And A switch 2 should have a next top of D switch 2, which should be 192.168.100. Excuse me, 192.168.200.15. So that should be this one right here. Okay. So on A switch 1, let's pull up our topology again. Let's do a configure terminal, and let's do a IP default gateway of 192.168.100.15. Okay, and let's go to A switch 2. Pull that device up. Let's do an enable. Let's do a configure terminal, and let's do an IP default gateway of 192.168.200.15. Okay, hit enter there. All right, so number 3, it says from A switch 1, ping D switch 1's interface and D switch 2's VLAN 100 interface. The ping should now succeed. So let's go back to A switch 1, and let's try to do that ping to, let's do an N first. Let me go back down. Let's do an N, and let's do a ping to 192.168.100.1. That ping is now successful because we configured the default gateway. And let's do 192.168.100.2, and that ping is also successful now. So that was the reason why. The reason why is because these are layer 2 switches, and they need a default gateway to forward traffic to if they do not know, if they do not have a, if they're layer 2 switches in general, they need a default gateway to forward layer 3 traffic. Okay, so from D switch 1 and D switch 2, ping router 2's fast Ethernet 2.0 interface, router 3's fast Ethernet 1.0 interface, and router 1 serial 0.0 interface. Note which ping succeed and which fail. So let's go to D switch 1, and let's do a end. Let's do a ping to the first IP address of 192.168. Excuse me, not 192. 198.51.100.1. So that ping is successful. That is to router 2's fast Ethernet 2.0. Let's do a ping to 198.51.100.2. That ping is successful. That is to router 3's fast Ethernet 1.0. Let's do a ping to 203.0.113.1. And that is to router 1 serial 0.0 interface. And that ping is failing. So the other two worked, but the one to router 1 failed. So let's go to D switch 2 and do the same thing over here. Let's do a N, and let's do a ping to 198.51.100.1. That ping is successful as well on D switch 2. Let's do a ping to 198.51.100.2. That ping is also successful. And let's do a ping to 203.0.113.1. That is the same one that failed on D switch 1. And this ping looks to be failing on D switch 2 as well, to that same IP address. All right, so it looks like D switch 1 and D switch 2 do not have routes to router 1 serial 0.0 interface, which is 203.0.113.1. So number 5 says on router 1, issue a command to configure a default gateway of last resort with an IP address of 203.0.113.6. So on router 1, let's do an enable. Let's do a configure terminal, and let's do an IP route. And it wants us to do a gateway of last resort. So we need to do 0.0.0.0, 0.0.0.0. And the next top should be 203.0.113.6. Okay. Now, number 6, it says on D switch 1, issue a command, issue the command to ping router 1 serial 0.0's interface. the ping should fail. So on D switch 1, let's do a ping to 203.0.113.1. So the pings are failing like it said it would. So number 7, it says on D switch 1, issue the command to configure a gateway of last resort through router 2's next hop IP address of 198.51.100.1. So on D switch 1, let's do a configure terminal. Let's do an IP route of O.O.O.O, O.O.O.O, and the next hop should be 198.51.100.1. Okay. Now number 8, it says from D switch 1, ping router 1 serial 00 interface. Note the type of failures the ping attempts report. So now let's do a end on router 1. Let's do that same ping to 203.0.113.1. And now we're getting used. So what used means, when we get used on a ping, that means that a device in between with D switch 1 and router 1, because we're pinging router 1, does not know a path back to us. And if we look, the only device that sits in between D switch 1 and router 1 is router 2. So router 2 is missing something within this routing table that is not allowing us to ping, or this ping to be successful. Okay. So number 9, it says on router 2. So now we're checking out router 2. Issue the command to configure a static route to 203.0.113.0/30 and a static route to 192.168.100.0/28 network. Okay. So on router 2, let's pull up router 2 right here. Pull up router 2. Let's do an enable. Let's do a configure terminal. We want to do 2 static routes. So we want to do an IP route to 203.0.113.0. We want to do a /30, so that'd be a 255.255.255.252 bit subnet mask. And the next hop, that will be up to router 1. So we need to look at the connection between router 2 and router 1. Let's go to our IP address table. So router 1's fast Ethernet is 203.0.113.5. So this should be for router, where we at, router 2. It should be a next hop of 203.0.113.5. So let's do a 203.0.113.5 as the next hop. Hit enter there. And let's do a static route, IP route of 192.168.100.0. It's going to be a /28 bit subnet mask. So it's going to be a 255.255.255.240. And its next hop will be down towards, we need to go down towards D switch 1. So we need the connection between router 2 and D switch 1. Router 2 and D switch 1. That should be 198.51.100.1. Let's go to D switch 1. It should be 198.51.100.3. Yep, should be that. So 198.51.100.3 should be the next hop. All right, so now on number 10, it says from D switch 1, ping router 1 serial 00 interface. The ping should now succeed. So let's see if the ping succeeds now. And it does. So we can now see that the routes that we just configured on each device worked. We're not able to ping from D switch 1 to router 1. Okay. So that means we have two-way reachability. That means that D switch 1 can reach router 1 and router 1 can reach D switch 1. So number 11 says on router 1, router 2, and D switch 1, issue the commands to display the routing tables. note how many static routes and gateway of last resorts are displayed in the output. So let's first pull up router 1. Let's do an N and let's do a show IP route. We can see that router 1 has a static route, gateway of last resort, and we can also see it in the routing table. We can see it has an S and an asterisk. Router 3, if we take a look at its routing table, let's do an enable. Oh, we didn't have to do router 3, so that's my mistake. We just need router 1, router 2, and D switch 1. So let's go to router 2. Let's do a show IP route. We can see that a gateway of last resort is not configured on router 2, but we have a static route right here, and we also have a static route down here. All right, so that's on router 2. We have 2 static routes. On router 1, we had a static route, and it was a default route. And now let's take a look at D switch number 1. Let's do a show IP route. We can see that D switch 1 has a gateway of last resort, which is a default route. And we can see that is right here. We can see that it is a static default route by the S in the asterisk as well. All right. So on number 12, it says on router 1 and router 2, issue the commands to remove all static routes and gateway of last resorts from those devices. Okay, so let's start on router 1. It wants us to remove all static routes and gateway of last resorts. So let's do a no IP route to O.O.O.O. Oh, let me do a configure terminal first. That'll be smart. Let's do a configure terminal. Let's do a no IP route of O.O.O.O. O.O.O.O. 203.0.113.6 to remove that route. And let's also do the same thing on router 2. It wants us to remove our static routes and default routes. So let's do a configure terminal. Let's do a no IP route. Let's do a no IP route of 203.0.113.0, 255.255.255.252 with a next hop of 203.0.113.5. Okay, that was the first one. Let's do a no IP route of 192.168.0. No, 192.168.100.0. 255.255.255.240. And let's do the next top was 198.51.100.3. Okay. Let's do a N and let's do a show IP route. Yep, all static routes are removed. Let's do the same thing on router 1. Let's do an N and let's do a show IP route to confirm. And yes, all static routes and gateway of last resorts have been removed. So number 13, it says on D switch 2, issue the commands to configure a gateway of last resort through the next hop IP address of 198.51.100.2. So on D switch 2, let's do a configure terminal. And it wants me to do a IP route of O.O.O.O, O.O.O.O, 198.51.100.2. Next hop. Okay. On number 14, it says on router 1, issue the commands to configure a static route to 192.168.100.0/28 network and the 192.168.200.0/28 network to next hop IP addresses of 203.0.113.2 and 203.0.113.6. All right, so on router 1, let's do a configure terminal. Let's do an IP route to 192.168.100.0. Wants us to do static routes. So we want a next hop of 255.255.255 240/28. And the next hop should be 203.0.113.2. We want to do an IP route to 192.168.100.0. Let's do a 255.255.255.240. And a next hop of 203.0.113.6. Let's do an IP route to 192.168.200.0. Let's do a 255.255.255.240. The next hop of 203.0.113.2. 113.2. Let's do an IP route to 192.168.200.0. 255.255.255.240. With a next hop of 203.0.113.6. Okay. Now it says on router 2, issue the commands to configure static route to 192.168.100.0/28 and the 192.168.200.0/28 networks to a next hop of 198.51.100.3. Let me make sure I did that right. Yep, I did that right. Did that right. Yeah, did that. Okay, I think I did that right. Okay, I just wanted to make sure. On router 2, let's do a configure terminal. Let's do a IP route of 192.168.100.0 with a next hop IP address. Well, let's do a 255.255.255.240 and next hop of 198.51.100.3. Let's do an IP route to 192.168.200.0. 255.255.255.240. Next hop of 198.51.100.3. Okay. And number 16, it says on router 3, issue the commands to configure a static route to 192.168.100.0/28 and the 192.168.200.0/28 network to a next hop of 198.51.100.4. So on router 3, let's pull that router up. Let's do a configure terminal. Let's do an IP route to 192.168.100.0, 255.255.255.240, and the next hop of 198.51.100.4. Let's do an IP route to 192.168.200.0, 255.255.255.240. Next hop of 198.51.100.4. All right. So that looks to be the end of task number 2. Task number 3 says configure single area OSPF version 2. It says in this task, you will configure single area OSPF on router 1, router 2, and router 3. When the configuration is complete, you will be able to ping every IP address on router 1 from any PC in the topology. So number 1, it says from PC 1, ping every IP address that is configured on router 1. Only one of the pings should succeed. So on PC 1, let's go to our IP address table and let's ping every interface on router 1. So the first one should be a ping to 203.0.113.1. That is serial 00 on router 1. That is getting replies. So we got replies from that one. Let's do a ping to 203.0.113.5. So that destination host is unreachable. So we're not able to ping the fast Ethernet 01. Let's do a ping to 172.16.1.1. And that destination host is also unreachable. So the only one we can ping from PC 1 is the serial interface. All right, so number 2 says, from router 1, router 2, and router 3, configure OSPF router process with an ID of 1. Configure the router ID of 1.1.1.1, R2s, R3s, respectively. So let's go to router 1. Let's do a router OSPF with a process ID of 1. And let's do a router ID of 1.1.1.1. Let's do the same thing on router 2. Let's do a router OSPF with a process ID of 1. Let's do a router ID of 2.2.2.2. All right, and router 3 is going to get a similar configuration. Let's do a router OSPF process ID of 1. Let's do a router ID of 3.3.3.3. All right, looks good. So on number 3, it says on router 1, issue the command to display information about the OSPF process configured on the router. No network should be advertised by the router. So on router 1, let's do a do show IP OSPF. And we can see the routing process is number 1. We can see the router ID we just configured. And we can see also that no networks are configured within our OSPF. What was it again? The no network have been advertised. Yeah, so no networks have been advertised by this OSPF process yet. Okay, so on number 4, it says on router 1, issue the command to place the router into OSPF router configuration mode for OSPF process 1, and then configure OSPF to advertise the 203.0.113.0/30 network, the 203.0.113.4/30 network, and the 172.16.1.1/32 network in OSPF backbone area. So we are already in the OSPF process. So all we have to do now is do the network command. And let's do the network of 203.0.113.0/30. So that'll be a 0.0.0.3 for area 0. Let's do a network to 203.0.113.4, 0.0.0.3, area 0. And let's do a network to 172.16.1.1, 0.0.0.0, area 0. All right, that's good. So number 5, it says on router 1, issue the command to display the status of the OSPF process. You should see 3 interfaces advertised in the backbone area. So let's do a let's go back and let's do a do show IP OSPF. And now we can see that we have 3 interfaces configured in the area 0 or the backbone area. All right. So on number 6, it says on router 1, issue the command to display OSPF neighbor relationships. All right. So let's do a do show IP OSPF neighbor. We shouldn't have any neighbors because we have not configured any networks to be advertised on router 3 or router 2. So we get no output for the neighbor command. So number 7, it says on router 3, issue the command to configure OSPF router process number 1 to advertise the 203.0.113.0/30 network and the 172.16.1.3/32 network, and then repeatedly issue the show IP OSPF neighbor command to watch router 3 and router 1 establish an adjacency. So on router 3, let's do a network of 203.0.113.0, 0.0.0.3 for area 0. And let's do a network of 172.16.1.3, 0.0.0.0, area 0. And let's do a do show IP OSPF neighbor. All right, so we're in the exchange state. And now we should be in the full state because we just got that message. So we started in the X start state and then it went to the exchange state. We didn't see the X start state because I was still typing in probably this network command. But we can see it went from the exchange state into the full state. We can see that no DR or BDR was elected, and that is because I believe that is that's the point-to-point connection from router 1 and router 3. So no DR is elected on point-to-point networks. So number 8, it says on router 2, issue the command in OSPF router configuration mode to configure the networks on which the loopback 0 and the fast Ethernet 10 interface resides to participate in OSPF area 0. Then repeatedly issue the show IP OSPF neighbor command to watch the adjacency form between router 1. All right, so on router 2, we need to pull up the IP address table because it wants us to do the loopback 0 and the fast Ethernet 01. So the fast Ethernet 10 should be a network of 203.0.113.6 0.0.0.3 for area 0. And the next one should be the loopback 0. So let's do a network of 172.16 172.16.1.1.2 0.0.0.0 area 0. Let's do a do show IP OSPF neighbor, and it came up so fast it's going to already be in the full state, but it's all good. We know it went through the X start and the exchange state. I can't type that fast, but we are now in the full state. So now it says on router 1, issue the command to display the OSPF neighbor relationships that have been established on the router. So router 1 should have adjacency with router 2 and router 3. Let's do a do show IP OSPF neighbor. And yep, we can see we are neighbors with router 3 by the router ID and router 2 by the router ID. So now it says on router 1, router 2, and router 3, issue the command to display the routing table. Each routing table should now contain OSPF version 2 paths learned from other routers. So if we do a N, we do a show IP route, we can see that we have OSPF routes in here by the O. Okay. We could do the same thing on router 3. Let's do a N and let's do a N. Let's do a show IP route. We can see the OSPF learned routes right here by the O's in the administrative distance of a 110. And router 2, let's do a N and let's do a show IP route. And we can also see the OSPF routes noted by the O. All right. So number 11 says on router 2 and router 3, issue the command to configure router configuration mode to configure OSPF to advertise the 198.51.100.0/28 network in area 0. So on router 2, let's do a configure terminal. Let's do a router OSPF 1. Let's do a network of 198.51.100.0.0.0.15 for area 0. Let's do the same thing on router 3. Let's do a configure terminal, router OSPF 1, a network of 198.51.100.0, a 0.0.0.15 area 0. All right. Now it says from PC1 attempt to ping every IP address that is assigned to an interface on router 1, the ping should now succeed. So let's try that again on PC1. Let's do that first ping to 203.0.113.1. That ping is successful. Let's do the ping to 203.0.113.5. That ping is successful now. Before that one was having a destination host unreachable. And now let's try the loopback 0 interface 172.16.1.1. That host was unreachable at first as well, and now we're able to ping it. So that looks to be the end of this lab, a pretty long one, but all good. We learned a lot. Let's hit grade. And we did something wrong on router 2, so let's figure out what we did. Oh, okay, so I misconfigured one of the network statements. This should be 203.0.113.4. Okay, so instead of .6, all right. So that was on router 2. So let's do a no network of 192.168. Let's see which one it was. Let's do a do show IP protocols. So that should be no network to 203.0.113.6 0.0.0.3 area 0. All right, and let's do a network to 203.0.113.4 0.0.0.3 area 0. Let's try that again. Let's give it some time to renew that adjacency and see what it does. Hopefully it comes back up to the full state. I think that was the correction that it wanted. Let's give it some time. Let's do a do show IP OSPF neighbor. Yep, so we're in a two-way state. Two-way state. Let's hit grade again, see what happens. Yep, so that was the fix. Just the misaddress on the route that I configured. But I appreciate you guys for watching this one, and I'll see you in the next one.